This is Professor Pelton. This is part 3 of chapter 5, section 1. All right, now we'll look at a couple that have factored form, or what's called intercept forms. It's already been factored. What's the benefit of this is we already have the x-intercepts, right? So the x-intercepts are -3, 0 and +1, 0, because it's already an intercept form, because I know that's because it's already factored. We'll think about why that is. We know that y is equal to 0, right? If you are in fact an x-intercept, y must be equal 0, right? So 0 equals -2, which is not true. 0 equals x plus 3. 0 equals x minus 1. So -3 equals x and 1 equals x, right? But you don't need to do that. We can just look at the actual form because that's the p and q that's given in the original factored form, right? Okay. So -3, 0 and 1, 0. Okay, you can put it in general form. So we'll do our math here. So f of x equals -2, x plus 3, x minus 1. So I get -2x minus 6 times x minus 1. And if I multiply again, I get -2x squared plus 2x, sorry, right? Two negatives make, so that's -6x plus 6. So if I add like terms, I get -2x squared minus 4x plus 6. All right, so that is my general form of the quadratic, right? That's the general form. Okay, so we get our vertex two different ways. One, we can do as typical formula, h equals -b over 2a. All right, so I get -4 over 2 times -2. So I get 4 over -4, or simply -1, right? So x equals -1 is our axis of symmetry, right? Which we also know is halfway between the two x-intercepts. So that's the other way you can get it if it's already in factored intercept form, right? We can get our y value now by plugging it in, right? So we can get f of -1 will be our k value for the vertex, right? So we have -2 times -1 squared minus 4 times -1 and then plus 6, right? So we get that's going to be a +1. So that's -2 plus 4 plus 6. So essentially it's 10 minus 2. So that's what? 8. So my vertex is -1, 8. Okay. So -1, 8 is right there. So it goes down. Wait, let's do the y-intercept. Sorry. Y-intercept. We know that x is 0. So if we plug in 0, we get y equals -2 times 0 squared minus 4 times 0 plus 6. So we get 6. 1, 2, 3, 4, 5, 6. And symmetrically on the other side. We get our parabola, which points down, which makes sense because the a value is -2, so it points down. Okay, oh, domain and range. All right, so domain and range. So quadratic functions go forever left and right. This one goes down forever, but only goes up to 8 and stops. Okay, all right, let's pause the video, try the student problem for yourself. Okay, so let's first get our x and y intercepts. So our x-intercept is 6, 0 and 2, 0, because that's the p and q values from the factored form, right? You can set it equals 0 to solve if you want. So 2, 3, 4, 5, 6 goes right there. So our y-intercept, you plug in a 0, right? So if I plug in a 0, I'm going to get y equals 1/4 times -6 times -2. So that's really 1/4 of 12, so 3. So 1, 2, 3 is the intercept there, and we have to go the other side symmetrically, and we get a point there. So obviously this one points up because it's a value of 1/4, right? We can put this in general form. Excuse me. So f of x equals 1/4 x minus 6 and x minus 2. So f of x equals, we'll multiply the other ones first. So we get x squared minus 2x minus 6x plus 12. So f of x equals 1/4 x squared minus 8x plus 12. So we distribute the 1/4. I get 1/4 x squared minus 4x. I'm sorry, 2. 8 divided by 4 is 2. I'm just copying the 4 down. And then 12 divided by 4 is 3. Okay, so that's my general quadratic form or quadratic general form, right? So there's two ways I can get to the vertex, or at least the x value. This is halfway in between, right? So that's what, 1, 2, 3, 4. So x equals 4 is the axis of symmetry. Okay, which you can obviously do this way. H equals negative b over 2a. So I get negative 2 over 2 times 1/4, or 2 over 1/2, or essentially 4, right? You copy dot flip. Okay, so f of 4 is our k value, right, for the vertex. So we can plug it into the original if we want, or the new one, doesn't really matter. So plug it into the original. How does that sound? So 4 minus 6 and 4 minus 2, just to kind of mix it up a little bit, because you can plug it into the general form or the factored intercept form. Okay, so what do I get? I get 1/4 times, what do we have here? Negative 2 and positive 2. So that's going to give me negative 1. So the vertex is 4, negative 1. Okay, so 4, negative 1, that's right there. So it goes up like this and up like this, which makes sense because it's a positive a value, right? So domain and range. So quadratic functions go forever left and forever right. This one goes down to negative 1, but goes up forever. Okay, so knowing the general idea of they go up and down forever, but left and right, I'm sorry, they go left and right forever for domain, but up and down depends on the a value being positive or negative. We can figure out max and mins as a result. Okay, so essentially, if the parabola points up, okay, you can only have a minimum. If the parabola points down, you can only have a maximum, which really comes down to the a value, right? That first coefficient in the quadratic function. If it's a is 0, then you don't have a quadratic, essentially, right? You have something else. It's probably linear or constant. Okay, so let's try some of these here. All right, so clearly this is a positive one, right? So therefore this must go up, which means this coordinate is clearly a minimum, right? All right, so we can do this a variety of ways. We can do h equals negative b over 2a. So we have negative 2 over 2 times 1/2. So we have 2 over 1, so essentially 2. So the k value is f of h. So we have 1/2 times 2 squared minus 2 times 2 minus 1. So that's 1/2 of 4 minus 4 minus 1. So essentially I have 2 minus 4 minus 1, or negative 5 plus 2 is negative 3. Okay, so 2, negative 3 is the location of the minimum, right? So that from that we can ascertain our domain and range. So obviously domain is going to go forever left and right. That doesn't change for any quadratic function. This is going to go down to negative 3, but up forever. All right, Pause the video, try the student problem. Okay, so this one has a negative a, so clearly this has a maximum. We're going to figure out what that maximum is. Okay, so h equals negative b over 2a. So negative 5 over 2 times negative 1, right? Because that's a, that's b, that's c. So we have negative 5 over negative 2, or simply 5 halves. Okay, so k equals f of h. So we have negative 1 times 5 halves squared plus 5 times 5 halves plus 9. Okay, so that's going to be negative 25 over 4 plus 25 over 2 plus 9. So you need to make common denominators. So negative 25 over 4 plus 50 over 4. So if I times it by 4, I get what, 36 over 4? So what I really have here is 25 plus 36. That's what, 61? So 61 fourths. Okay. So 61 fourths. Right, so 61 fourths is the max. The max location is at 5 halves 61 fourths, right? So the coordinate is the location and 61 fourths is the max because these could represent something. Could be height, could be number of dollars, pancakes, punches to the face, who knows what it is, right? All right, so domain and range. So all quadratic functions go forever left and forever right. This one goes down forever, but only goes up to 61 fourths. Okay. All right. Pause the video. Try the student problem. Oh, the next student problem, sorry. Okay, so the next one, this one clearly points up because it's a positive a value, right? So a, b, and c. So this clearly points up. So this coordinate is a min, right? Whatever this h and k value is, who knows? And we'll figure out the domain and range from that. So before I even start, I know I can answer a lot of this because I know the domain is going to go forever left and forever right. This is going to go forever up, and it's going to go down to some value, which you're going to determine, right? So h equals negative b over 2a. So you have negative 16 over 2 times 4. So negative 16 over 8. So negative 2. Right, so this is at negative 2 is the location, and k is the actual min. So that's f of h. So I get 4 times negative 2 squared plus 16 times negative 2 minus 3. So that's 4 times 4 minus 32 minus 3. So that's 16 minus 32 minus 3. So that's negative 16 minus 3. So what do we have? Negative 19? Okay, so negative 19 is the minimum. And the location is at negative 2, negative 19. So this goes down to negative 19 and then up forever, right? That is the end of part 3.